Okay, for anyone that has installed Unity, okay, please open up your Unity hub. It looks like this, right? Okay, and then click on New Project. Then select 2D, and then give it any name. Okay, give it any name. I'm just gonna put this GameStart. Okay, give this project any name, and then click on Create Project. This is going to take another 5 to 10 minutes to initialize. So we are going to do it now before the workshop officially starts. Okay, just click on it. Now, has anyone not done that yet? Why? Sure. Okay, and this is a reminder. Please download it if you're not already before you create. I'm going to give you guys about 5 minutes now to set up. Okay, and then so that you can easily, if you haven't already, you can create a 2D project while it's for a while. Okay. If you aren't in our Discord server, you can scan this QR code to join. Does anyone need this? Yes? No?
May I start question?
Yes.
When I tried to install it seemed to going fine, but it didn't prompt me to install no virtual code, no web OpenGL, no anything, no.
It's in the installation prompt. So if you click on New Engine, you install, then it's going to ask you what you want. You need to install the engine. It's not just Unity Hub. Okay.
No, I already installed Unity itself, and I can open the one that was set in 2D.
Okay.
But it didn't prompt me to like choose anything.
Sure. You can click on here, and then installs, and module.
Oh, I see. Yeah.
Okay. So if anyone that has installed Unity and hasn't configured for Visual Studio or WebGL, you can do so by going to Unity Hub and then go over to Installs and click on this engine version and click on Add Modules. And you can see all the stuff that you can add here.
It's so weird.
And you can install the necessary modules. So typically I'm going to recommend you to use Visual Studio because it has the best integration with Unity development. It allows you to do things like autocomplete, and then it's also going to give you some level of suggestion based on what you're writing. And we are also going to use WebGL because at the end of this workshop we are going to publish a game to itch.io. Has anyone here not heard of itch.io? Sure, okay, it's just a website. We're going to talk about that when the time comes. Okay, so this is the attendance QR code. For anyone that hasn't scanned their attendance, please do so that we can show to NUS that this workshop is here. Okay, this workshop is ongoing. So if you haven't scanned the attendance QR code just now, please do it right now. I'm going to keep this here for a couple of minutes. Okay. So has anyone not scanned the attendance yet? If it's too small, you can move forward and scan it. The link is quite long, which is why the QR code is quite huge. Okay, are we good? Are we good? Okay, so we are going to start with a brief introduction. I've talked about this during the welcome tea, but I'm pretty sure some of you guys haven't attended the welcome tea yet, so I'm just going to quickly go over it. So when it comes to game development, you're going to need a game engine. game engine is kind of like Visual Studio Code. It's like VS Code, but it's for making games. So it has a very convenient editor that allows you to quickly edit and modify all the game scenes in your video game, so that it kind of facilitates your process of creating them. Besides that, a game engine already has all of the underlying kind of very difficult mechanisms all implemented. For example, physics, rendering, lighting, all of these, the game engine is going to handle it for you. So it facilitates the development process. It allows you to have a ready-to-use environment, there's a typo there, such that you can focus on designing the game rather than trying to figure out what is the kinematic equation for velocity. Okay, that's not important for you. And it also provides cross-platform support. So if you check the Unity modules, you'll notice that it can build to everything. It can build to Android, it can build to iOS, it can build to Ubuntu, it can build to Windows, it can build to macOS, it can build to tvOS, it can build to Xbox, PlayStation, VR, AR, whatever platform that you can game on. Unity provides you the ability to build to that particular platform. So you can make one game in the same editor with the same project and build it to 10 different platforms. That's completely possible. And this facilitates your development process as well, because you don't have to write 3 different versions of code for a single game that you want to build on PC and mobile, right? And it also has a forums or Stack Overflow ChatGPT option. I'm pretty sure everyone knows what these things are. Does anyone not know what is ChatGPT? Has anyone not used it before? You have not used ChatGPT? Sure, okay, sure. You'll soon use it. Okay, you'll soon use it. But it's not going to help you it's not going to help you get better at coding. It's just a tool, so use it in moderation. So, does anyone not know what is Stack Overflow? There is no way, right? Sure, okay. So there are 3 popular choices for a game engine nowadays. The first one is Unity, which is what we're going to be learning in this workshop. The second one is Godot, which is what they'll be learning in that other workshop now. And there's also Unreal Engine, which is the more advanced kind of engine that is usually not very suitable for beginners, which is why we're not teaching it here. So why should we learn Unity? It's free, and you don't have to pay Unity a single dollar until you make $100,000 of income per annum on your game. Okay, you don't have to pay the company a single buck. Okay, it's easy to learn. Later we're gonna get through it. You'll find out that it's really not that bad. Okay, it's well documented. It's got a whole website on the Unity website that dedicates to explaining all the different Unity Engine APIs that are available, so that you can just look it up when you don't know what a particular API method does. It has an active community, so there are hundreds of thousands, maybe millions of Unity developers out there, and most of them are active on the community forums, so you can just look it up. Maybe one of the problems that you are facing right now has already been solved by someone a few years ago. It has a large number of assets. We're going to get through this next week. But there is an asset store that allows you to download free or just buy paid assets. And you can use these assets in your game and publish it. Okay, it's completely yours after you get them. It has multi-platform support. As I have mentioned just now, you can build to any platform that is available for games right now. And it's also the most widely used engine based on market share. So there's about a 29% of game developers using the Unity engine right now. Okay, good. So this is a rough timeline of what we are going to be doing in these 4 weeks. So right now we are week 2 is setting up and player controls. Setting up takes a long time. I'm also going to get you through all the components in the Unity engine, in the Unity editor. So it makes future teaching much easier. Okay, week 3 we are going to go into asset store, level creation, play interaction, and some UI. Week 4 we're going to go into instantiating object animations. And week 5 we're going to go into object pooling and GitHub integration. So week 5 is the more advanced kind of thing that you're expected to do after you kind of get into the industry better. And GitHub integration is especially important if you're going to participate in our week 5 game jam. So there's going to be one right after GameStart so that you can, you know, show off your skills, what you have learned, okay, with a group of 4 to 5 people. And GitHub is going to be important. It's going to be 5-star important for that game jam, and it's also going to be very important going down further the line. So, with that introduction out of the way, we can start our development process. And let's get started. So remember that I said we should create a 2D project just now. And if you have already done so, after the long 10 minutes wait, you should be greeted with this interface. Has anyone not created the project yet? Please raise your hand. Okay, that is still installing. Installing. Verifying.
I'm creating.
Creating, okay. Sure. Okay, as I say, it takes a long time, which is why I wanted you guys to kind of do it beforehand. But that's fine. We're just gonna do a quick tour right now. So this is the Unity engine. Can everyone see my cursor? Yes? It's got a blue highlight over there so that you have better visibility. So in this layout, there are a few things. The first one is the toolbar ribbon. So you have file, edit, assets, game object, components. These ribbons you most likely won't use that much in the future as well. So it's not really that much important. But the most used one is probably going to be file, because at the end of your development cycle, when you want to build your game such that it can be played on different platforms, you're going to be using this one. Edit, assets, these are just kind of, it's not really related to beginners level, so we're not going to go through them. So over here, you can see a hierarchy. Okay, you can see a hierarchy. Let me check if the mic is on. Okay, yeah, it is. Okay, so over here you can see a hierarchy. So this hierarchy contains all the game objects inside of your game scene. What are game objects? Game objects essentially just, you know, whatever that is in the scene, we call them a game object. So for example, if you put a ball in the scene, the ball is going to be a game object. You put a player in the scene, the player is going to be a game object. Okay, you put a bullet in the scene, the bullet is going to be a game object. So basically, whatever that appears in the game scene can be considered as a game object. Okay? And so all the game objects show up in the hierarchy here. And if you have used the hierarchy before, you probably know that there are things like parent-child kind of relationship. We are going to go through that in future workshops. So over here, there is a scene view. So in this particular, I'm pretty sure you guys probably have it like this, right? This is like the default layout. But this scene view is going to be a very quick editor that can be used to modify your scene. So if you guys have used photo editing software like Photoshop before, this works quite similar to that. So you can edit your game scene inside of this scene view. Okay, and all your edits, they're going to be shown in this game view right here. So you can see in real time what is going to show up. So let's do a quick example. For example, I can right click and create a 2D circle object here, and you can see it shows up in the scene view, it shows up in the game view, and if I move this around, it will also move in the game view. Okay, so this kind of gives you like a two-view perspective, so you can kind of see what your edits actually bring to the game view. Okay, so it's like a preview there. So over here, you can also kind of customize their position. As you can see, I drag this around, and it kind of just, you can just put it there. However you like it to be, it's highly customizable. So, personally, I like split view a bit more, which is why I put it this way. But feel free to mess around with it to get an interface that you like. So over here we have the inspector. So an inspector shows you all the properties of the game object. So the basic property of a game object is the transform property. So it contains all the positional information and the rotational information of a particular game object. So if I move this around, you can see that the position changes. Okay, so these are all the basic things. So over here we have a project tab and a console tab. So the project tab shows you all the assets available for your game. Right now, because there is nothing, so we only have a single game scene. In Unity, every single level is stored as a game scene. So if you have multiple levels, you'll have multiple game scenes. But right now, since we have nothing, we only have one, which is the default game scene. It's called sample scene instead of scene 1 or whatever, so that it kind of differentiates itself. But sooner or later, once we start adding more assets to the game, you're going to see this folder getting a lot more bloated. Okay, that's completely fine, and that's completely okay. It's just like creating some software in other programming languages. You install any modules dependency, and then the entire thing becomes 5,000 items. That's a small rant, but anyways. So, and then we have a console view. So here it shows you anything that happens when the game is running. So it gives you some basic debugging tool. So if you have any kind of programming experience before, there's probably some kind of way that you can print your program onto the console, and this is where it's gonna show up. So if you do something like print hello world, it's gonna show up here. Okay. So these are the basic components. Sooner or later, we're gonna go into more components that does not usually show up on the basic default view, but this is the default things that we are going to be touching today. So let's get started. So let me remove this circle object. Okay, so when we are starting this off, we are going to, of course, just make a simple prototype. If you have experience in programming, you should know that the first step is always to do some kind of hello world, so that you kind of know how the language does. So Unity is kind of similar, so you kind of want to make a very simple game scene. So we are making a platformer game scene. So can anyone tell me what is the main aspect that should be in a game scene for a platformer game? Platforms and?
At least one character.
At least one character. What kind of character?
I mean, you don't.
Playable character. Okay, so
Yes.
okay, we're talking about like the general type. Okay, like what is the stereotypical platformer? So platforms, playable character. That's correct. So we're going to put these two inside. So over in your game scene here at the hierarchy table here, you can right click. So if you can see, I set up right click is like pinkish. Okay. So if you right click, you can see the 2D object. So since we're making a 2D game, we're just gonna do this. So over at sprites. So sprites is kind of like an image file. We call them sprites in Unity. Actually, we call them sprites in game development in general. So you just create a 2D sprite, and we're gonna create a circle. So this should pop up. And you can rename this in the hierarchy view. As you can see, it's highlighted right now. So let's just call it player. So our player is just a very boring circle right now. But we're going to work on something more interesting in the next session. Okay, and let's make a platform. So what do platforms typically look like? Rectangular, that's correct. So we can create a 2D sprite and just select square. Why is it a square? Because you can make it a rectangle. So over here, if you look at the transform here, these are the transform toolbars that we are going to use. And this is the move tool, so it allows you to move the things around. And there is also the scale tool, that once you select, you can kind of scale it in one direction or another. And there is the rect tool that allows you to resize this on one end. So it's just like photo resizing. So right now we're just going to make this extend over the entire game scene. So yeah, right now we have a player, we have a platform. Let's make sure we rename this as a platform. So surely this is enough. So we can click on this play button at the top here to preview our game. And it takes a while. Usually on the first play only. Hi.
Is this for the game development?
Yes, this is a Unity workshop. Please take a seat. So it's playing. As you can see, the blue button is light up, but it's not doing anything. So the reason why it's not doing anything is because all of these are just images right now. As you can see, in the component, we only have a positional data and the data for the sprite, but nothing else. So in order for this to interact with our game, we need to give this a little bit, we need to give this more components. So components are, well, components that has different properties that allows your game object to act according to that property available. So for now, we're going to give this player a rigid body 2D component. So you can just click on add component and you search rigid body and this will pop up, rigid body 2D. So just click on it and it's going to add it onto itself. Has everyone done that? Yes. Okay, so you select the player object here and you'll see that it shows up on the inspector. Then go to the bottom, click on add component and type rigid body inside of this small search box here, and then select the rigid body 2D component and click on it. Then you will see this rigid body 2D component shows up in this inspector. This means that it has been successfully added. Alright, is it clear? Is anyone stuck? Okay, please, the guy beside him help her. Okay, so we're gonna continue first. Now at this point, you're going to ask, what is a rigid body 2D component? Why should I add it? So a rigid body 2D component is a component that allows the game object to simulate game physics. Does anyone not know what is physics? Sure. Okay. Why are you getting pulled down onto the ground? That's because physics, okay? It's like the basics of science. I don't accept if anyone not know. Sure, okay? But, okay, so it simulates game physics. And the game physics are controlled by Unity engine. So Unity is going to... Anyone out there? Okay. I thought I heard it now. But anyways. So Unity is going to control this game object such that it will follow its implemented physics. So as I mentioned, a game engine has already done all of the very technical implementation, and one of them is physics. So if you attach a rigid body 2D component onto a game object, it's going to follow Unity, Unity's implemented physics, so that it acts as if it's got physics. Okay? So a rigid body an object with a rigid body 2D component is affected by force and collision with other game objects. And it has these properties. It has mass, it has gravity, it has drag, linear and angular drag, which is what makes them kind of slow down if there's no additional force pulling onto it, and velocity, which is just speed but with direction. Okay, it's more technical term. Has anyone here not taken physics during high school? Okay, yeah, that's interesting. So it might sound a bit out of place, but it should be fine to understand. So after attaching this rigid body to the component, surely at this point this thing would fall onto the platform. Okay, no, it falls right through. And the reason is because the collision is only going to happen when two objects have rigid body 2D on them. So let's apply this onto our platform as well. Surely this will work. Oh, okay. So any ideas why that would happen? We need to make the platform not fall, correct? Okay, someone here is a game designer genius, okay? So, in order to make that not fall, we need to change the body type. So there are three body types for a rigid body component. And the first one is a dynamic type, which is the default type. So a dynamic rigid body type would simulate all game physics. Okay? But kinematic and static ones are slightly different. For now, we're just going to change it to static. And let's explain what's the difference. So kinematic rigid body types, they are not affected by gravity and force. So it will not fall according to gravity. It has velocity. It can change position. But it has infinite mass, which means it will not be affected by outer forces. A static rigid body, on the other hand, even though it's very similar, but it is completely immovable. So with a kinematic rigid body, you can actually change the position of the object by changing its velocity or just changing its position data. But a static rigid body object, they cannot be changed outside of the editor. So for something like a platform, where you don't want the player to mess around with it, static rigid body will obviously be the better choice. So let's do that, and let's make sure that we have static here, and let's play. Surely this will work now, and it still falls over. Any ideas? Collision, yes. So even though rigid body objects, they detect collision, but we did not tell the object that they should detect collision. Okay, which is why we need to give these objects a collider. So what is a collider? Anyone guess what's a collider? Yes, the guy in the yellow shirt.
It's a completely separate component that you can find by searching collider in the search box.
Okay, and? What does it do? Okay, anyone can guess what does it do? What does a collider do?
Prevents clipping or like.
Prevents clipping, checks for collision, that's correct. So if you have a collider component on a game object, it will make the game object check for collision. So let's do that. So we select the player object again, and here we are going to add a collider. So we are going to add a circle collider 2D. So just click on add component, search for collider, and there is the circle collider 2D object here. Just click on enter. And that's it. Okay, at this point this should work. I hope. Clearly it didn't. Does anyone know why? The platform does not have a collider, yes. So in order for two objects to collide into each other, both of them needs to have the collider component. So let's do that. And for the platform, we are going to add a box collider 2D. And at this point, the game would work. So it took a whole long way here. We finally get to this point. But what's next?
Tilt the platform so that your player rolls off the stage.
Okay, tilt the platform. No, I'm not gonna do that. I'm not that cruel. Okay. Yes. Program the ball to move using keys. Okay, yes. So for any games to feel interactive, we need to have some kind of player input. So that the player can actually interact with the object and make it move, for example. So for that, we are going to start going into programming. Anyone here hates programming? I hate writing a line of code. Whoa, okay, sure. Maybe this course is not for you, but it's okay. So let's start. So in order to do that, first of all, we are going to maintain a good folder structure. So inside of this project view here, we're gonna go to assets folder. You're gonna see scenes there. You're gonna right click and click on create and select folder at the very top. So we're gonna give this folder a name. We're gonna call this scripts. Okay, is everyone following? It's called scripts. Okay, SCRIPTS. Scripts. Okay? Now open this folder up. And this is completely empty. And we're gonna start adding some C# script onto this. So Unity uses C# for its as its programming language because it's easy to use, it's easy to learn, and it's not syntactically hard like C++. And it's good enough. It's good enough for basic development. So just right click create and you should see a C# script right below folder, and click on this, and we're gonna give this a name. So we're just gonna call this player movement and click on enter. Once you have done that, the editor should pop something up like a loading bar, and you can double click on it and this should open up Visual Studio if you have configured it correctly. If you have not, this should pop up your favorite icon. Unless you are using Vim or Emacs, okay, you are on a completely different breed, so I'm not gonna talk about that. But if you have Visual Studio configured, you're gonna know why we're gonna use it further down into this one. So once you've opened this up, you will see that we have a start and an update method already defined. Well, it's written out, but there's nothing in there. So for every game object in Unity, it inherits the monoBehavior class so that it's labeled as a game object. And for every game object, we have a start and an update method. So start is called when the game object appears in the game scene. So for example, when the game scene starts, okay, when you click on play, the object appears. And then and then the start method is called. So anything you write in the start method should only be called once when the game object appears on the screen. So let's do a quick example. For example, we want this player object to say hello world. Okay. So in order to do that in Unity, you're going to need to use debug.log. So this is just like console.println or something. And you just give it a string. So this is going to be useful in the future when you're doing a little bit of debugging, not too advanced debugging. Usually you just add a few debug statements. So after you do this, you're going to save the script. Make sure you save the script. Okay, and once you get back, it's going to compile. And as we click on play, nothing happened. And that's because the script is not attached to any game object. So in order for the script to execute, it has to be attached onto a game object. So for now, let's just attach this onto the player game object. And you can do this by dragging and dropping it to the add component button here. And this will show up as a script. Okay, are we good?
Go back to
Go back a little.
the
Okay, so
the C# file.
the C# file. Yes, it's just debug.log. Is it too small? Should I zoom in? How do I? Oh. Is this better for the one sitting at the back? Yes? Because I can't see any lines of code on my PC. Is this better? Can everyone see this line of code? Good. Okay, good. So now once that we have attached this script onto the player object, we're gonna save the scene and we're just gonna play. And now you can see the hello world popped up, and if we go to console, it's going to show up here. This means the script is working and it's only being called once. But there's also a second method here called update. So an update is called on every frame update. Does anyone not know what is a frame? Anyone here not a hardcore gamer to know what is FPS? Yes. Don't be shy. Okay. Good. So frame is essentially when the game updates itself. It's going to call an update. So by default, Unity locks the FPS to about 60 in the editor unless you specify to go higher. So in theory, if we add a debug.log, I don't know, something like goodbye world here, make sure you put the semicolon, it's going to show up about 60 times per second. So if we play, yeah, it's just about that. So now that we know what the start and update do, okay, can anyone guess where should I put an input detection? Update, yes, why? Any reason why? Why should it be an update?
It should always be checking.
It should always be checking, correct. So imagine you're playing CSGO. Does anyone not know what is CSGO? Okay, imagine you're playing CSGO, but the input is not being checked. It's not always being checked. So when you're trying to press W, you delay for about 10 seconds before you can move. Is that a good experience? Who said yes? I think I heard someone say okay, maybe. Okay, but effectively, when you're trying to make players feel like it's responsive, it should always be checking. So how could we do that? Let's start writing some actual code. Okay, these are just some beginner stuff that I'm pretty sure everyone would know how to do. So let's remove these debug statements because we don't need them anymore. So let's start with very basic. We want to know how we could get input from the keyboard. So we should just check if the input is active. So let's just start with input. And as you can see, Visual Studio already knows what I want to do. So we can do input dot get key. Okay, get key down. So get key down returns true when the player presses down onto a button. Okay, so we're just gonna do input dot get key down. So this is one of the things that Unity has already implemented for you, which is input detection. Okay, so you just need to do this. So we are also gonna need to give this a key, and for this, usually you're going to give it a key code. So just type in key code here, and we're just gonna give it something. For now, let's give it W. So when the player presses W, what do we want it to do? So when the player presses W, we want it to be able to move potentially. But for now, let's keep it simple. We're just gonna let it print. I'm pressed. Okay. So that we can verify that this works. So let's get back to the game scene. Let's click on play. And now, if we press W, you can see that I'm pressed is being shown on the screen. This means that the input detection is working. So we are going to have to make it do something. We're gonna have to make it do something. Yeah, don't forget your semicolon. We are not writing Python, we're not writing JavaScript. In C# you need a semicolon. Okay, that's out of the question maybe. So now that we know the input is working, we need the input to actually do something. So what should the input do?
Move the character to the right.
Move the character to the right. Okay, but usually we don't use W for that, right? So let's just change it up. Let's move the character to the right. Usually use D. Is anyone here not a gamer enough to know what is D? Okay, maybe. So we want to move the character to the right. And how we could do this is to just change the position of the object, right? Yes? If this game object appears here in this frame, and then we change the position here when they press, does it look like that they have moved? Does it? Does it?
No.
No. Okay. So how do you propose we change? How do we propose we make it move?
Apply a force.
Apply a force to it. Might be a bit complicated. Give it what?
Velocity.
Give it velocity, correct. So if we give it velocity, we should be able to make it move. How do cars move in real life?
So
Right, you just step on it and you see the speedometer go over 200 km per hour, and then you start flying. Right, so you give it a velocity. So how can we do that? So remember, just about 10-15 minutes ago, we have talked about rigid body 2D components having velocity because they simulate game physics. So we can change this velocity component. And how we could do that is just by doing this. So let's call a private variable, a private rigid body 2D variable. and we're just gonna give this a name RB. We usually use RB because it's short and it's kind of self-explanatory. So, but this is not being referenced or initialized. So in C# you always need to reference it. So when the object starts, we're going to reference this to get component rigid body 2D. So this would get the rigid body 2D component that's attached to the game object that this script is being attached to. So in this case, it's going to get the rigid body 2D component in the player object because this is attached to the player. So once we have done that, we want to change the velocity property in this rigid body 2D component. So for this, we can just do RB.velocity. Okay, we can assign this to a new value. So let's just make it simple, maybe. So for this velocity component, it takes in a vector 2 for a 2D space. So has anyone here not taken linear algebra in high school? Matrix, vectors, right? Matrices, vectors. This is about the same thing. If you haven't already, you can look it up. But essentially, this is just a two-dimensional number array that allows you to describe the x and y component. So x component is the horizontal component, and y component is the vertical component. Okay? So we want it to move to the right. So the right usually is going to be positive x. Anyone here not familiar with vector conventions in physics? No?
What?
Vector conventions. So going to the right is positive x. Good? Yes? Questions? Not really. So essentially every single frame you're assigning a new vector to it. You're not adding force. You're just changing the velocity value.
Which is a problem itself. It means that if you jump and then you press left, you're going to cancel your jump.
That might be a problem, but we're going to cross that later. So let's just do something. So we want to let it go to the right. Let's give it any value. And we don't want it to move to up, down, right, or whatever. So let's save that. Now if we play, as we press D, you can see that it now starts rolling towards the right. That's working. But I have to spam click because it's currently on get key down. Which means if you hold it, it's actually going to register it as one press. So if we look at the documentation of get key down, you'll realize that this means that it only returns true when the user starts pressing down the key. So there is a better way. There is a better way that you can detect user input for movement. There is a better way. Okay. Okay, is anyone still stuck with moving right? Please raise your hand. I can give you about a minute to recuperate. Okay, good. I'm going to stop this here for a minute. That's right. Okay. Sorry, we are severely out of schedule, but let's continue. Is anyone still stuck? No, okay. So there's actually a smarter way for you to detect an input from the player. So before we work on that, we are going to do a float called direction. So this will store the direction in which the character is moving. Does anyone not know what is a float? Okay, let's just do a quick introduction. So float is a data type, just like int and bool or any other thing. It's preferred in game development because it's small, it's faster to calculate, it uses less space to store, and the rounding errors are acceptable. So we don't use double because double is 64 bits. Float is only 32 bits, and it's used extensively in computer graphics and rendering. So I'm just quickly going through. You probably don't need to know why. You'll need to know why if you take CS 2100 after this. Okay, anyone has PTSD, you know what I mean. So, okay, so we store the direction, but we need a way to know what the direction is. So here we are going to update every frame. So we change the direction value every single frame. And we're just gonna say direction equals input.getAxis raw. So this actually will detect analog input if your keyboard has it, but it's not important. So we're just gonna keep this. So we need to give this axis a name, and this is horizontal axis. So by default, Unity detects horizontal axis input with the AD key, and I believe with the left-right arrow key as well. But usually it's for the A and D key. So A is left, D is right. Good. So we're gonna update this direction. So what should we change in the predicate statement?
If direction.
If direction, direction what?
Right. I don't know.
Okay, so if direction, so which means if we are actually detecting a direction, so the player is either pressing A or D, we want it to move. So let's look at what this getAxis raw return. It's a float value ranging from -1 to 1. When nothing is being pressed, it returns 0. So if something is being pressed, it's not gonna be 0. So we can just say if direction is not equals to 0, we change the velocity component. But right now it still only moves in one direction. So we want to make it such that it moves in two directions. So how can we do this? First of all, we want to be able to, so we just need to do this. And so it multiplies 1 by 1 or -1. So if we press A, it's going to go -1, so it's left. If we press D, it's gonna right. Does that make sense? Okay. So let's go back to here. And you can see now it moves in two directions. The problem is it kind of drifts a little. Sometimes you don't want that in a platformer game. Oh, it fell off the platform. Okay, so usually when we use direction, we would probably not use this predicate statement. And instead, we're just gonna put this out here. So even if it's not being pressed on, it's still going to reassign the velocity vector, such that if we're not pressing anything, the player would just stop on spot. So it depends on what kind of feeling that you want it to do. You want to get from your game, but we're gonna stick to this for now, so it feels a bit more responsive. So now if we press play, this is a problem. Okay, even though left and right kind of stop on point, but because we are setting 0 to the Y velocity on every frame. So as mentioned just now, this might be a problem. So how can we solve this? Any ideas? Any ideas how can we solve this?
I think we can detect first by if it
Okay,
is
first.
colliding with something or not. As long as it didn't collide with the floor, it shouldn't move, right? Until it
Okay,
collides with the floor.
detect until it collides with the floor. Too complicated.
Maybe like under components manipulated such that it reacts like Unity's initial kind of gravity function, like if they already have something installed.
Too complicated. There's a very simple way.
Wait, so
Just put -1 there.
-1, no.
wait, what are you trying to achieve? So what are you trying to achieve?
Okay, we don't want it to
Oh.
assign 0. Yes.
Assign like the current
Cyberpunk
velocity.
Yeah, just assign the current velocity. Brilliant. So we can just do this. That's the same value to the y component. So even if we are dropping, we are jumping up, it will not change even if we press A or T. Does that make sense? Yes? Good, correct. Okay. So we need to move a bit faster now. We don't have much time left. There's actually still a bit more. So now you can see that it kind of moves. Right? And even if we are dropping, it still drops as normal. That's good. That's what we want to do. So what else? What else? We are able to move left and right, but it feels a bit slow. So we probably want to increase the speed. But let's be honest, if you have to swap over to Visual Studio or VSC or whatever IDE every single time to change the value, you'll probably feel, why am I doing this? Okay. There's an easy way to do it in Unity. So first of all, have you guys noticed that all of these properties, they actually have fields that you can change? There's a way for you to add a field for your own script. So let's define a private variable, a private float variable called moveSpeed. But as you can see, the float private variables, they don't show up. So we can add this called serialize field tag in front of this float. So this is a Unity thing. It's called serialize field. Actually, in C# you can serialize, but I'm not gonna go into programming languages here. So let's just remember that this is a serialized field, and now you can see that the script has a moveSpeed component. So we can change this. Give it any value in the editor. We don't have to swap over here. But now we need to actually use this, and where do we use it? We just do here.
Can you scroll up?
Scroll up, yes. Serialize field. Okay, is anyone following? Anyone stuck? Assume no one's stuck. I don't think it's that high. It actually has an autocomplete for that. But let's go back. So as we change the move speed here, dynamically you will see that it changes. So right now we have it at 4. And let's push this to a higher value directly. Okay, so just a small tip. Things that you do, things that you change in GameObjects property in preview mode, they do not get saved in the editor. So you can change it to any large value here, for example 10. Okay, it says that you must exit play mode to save the scene. I don't care, but you see I'm moving much quicker right now. But as I exit, the move speed gets changed back to 4. Okay, so now we have a way for you to kind of like change it in the editor. You don't have to go into your scripts anymore. And this is going to be helpful if you have like tens or hundreds of scripts further down into the development, so that you don't actually need to know like which script to change the move speed component. It just shows up here. Just a useful tip. So now we can move left and right. Anything else we need to do to make it feel like a complete platformer?
Jump.
Jump! Yes, we need to be able to jump. So how do we know when to jump? when you push spacebar, so the same thing. So if input.get key down, key code dot space, we need to jump. So what is jump essentially doing? Adding an upward velocity, correct. So we just need to change the y component for our velocity. So for this sake, we're going to add a jump speed for here, such that we are able to also access this view. So once you're done with that, go down here, and we're just gonna say rb.velocity equals new vector 2. So do we want to change the x component? No. So same, we just x, and then for here we're just gonna add jump speed. Okay. Is it good? It's actually about the same thing. Starting to get a hang of it. Yes? No? Okay, let me scroll up a bit so you can kind of see. Okay.
Wait, but if this is the case, when you jump, you will just go up forever, right?
Okay, we're gonna get to that later. Okay, so right now, if you press space, you should be able to see that, oh, we're not jumping. Because we forgot to assign a value to jump speed. So let's just give it any value. Let's give it 5. We can jump higher than we can move. We can walk, okay? So now if we press space, wait. Okay, sorry, I accidentally exited. Okay, so now as we press space, you can see that we can jump. Okay, sure. Okay, is anyone not done with this? Yes? No? Yes? No? Okay, I'm just gonna put this here for another 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, is anyone still not done? Okay, I'm assuming everyone's done. Good. So, now we give this a jump, but as someone has mentioned just now, wouldn't this just mean that if I keep pressing spacebar, I just keep going up? Yeah, that's correct. So how should we fix that? Any ideas? How can we fix that? There are actually multiple ways to do it, but there are easy ways, yeah.
Detect for collision with the floors.
Detect with collision with the floor.
And only allow you to jump when you're with the floor.
Only allow you to jump when you're with the floor. We are actually only gonna do the second half. Because it introduces you to more Unity magic. Okay. So in order to do this, let's just go over here. And we need to know whether or not we are on the floor. Right. So in Unity, there's actually something called a layer. So a layer essentially is a kind of abstraction. I have it here. So it's actually a kind of abstraction that allows us to separate one object from another. So for example, if we look at our real world, we know that this is the ground. We have some kind of cognitive ability. This is the ground. This is not the sky. Okay, that's the ceiling. But in a game engine like this, programs are dumb, we all know, okay? So it isn't able to do that until we explicitly tell them this is the ground. So a layer mask allows us to have this convenience such that we can tell the program this is the ground, you're standing on the ground. So It allows us to separate one object from another, and it allows us to create a physics interaction, abstraction for objects, and it also allows us to selectively filter game objects for certain operations only. So how can we do this? First of all, we need to add a new layer. So if we go to layer here on the platform, click on default and click on add layer, you can define up to 32 layers. It starts from 0. So usually you don't use this too much. It's usually only for the ground. So let's just add a ground layer. So once you're done with that, you just click away and the layer is there. So now, as you go back to the platform object again, you can go to layer and select ground. Okay.
Wait, sorry, did you just create a ground layer?
Yeah, I just created a ground layer. That's it. You just select one of the layer and then get it a name called ground. That's good enough. So,
Wait, sorry, can you repeat that?
okay, you just click on add layer and then you just give it a name. Okay, you just give it a name. It's already there. Once it has a name, you can select it.
Is there a reason why we're not using user layer 3?
For simplicity. Not much of a reason you can use user layer 3. Depends on you, but usually it will be reserved for something more important.
Why is there one, like user-defined one right there in the middle of?
You need to ask the developers. I'm not part of the dev team, so I don't know what is the reason behind that. But usually I would keep the first few layers reserved for more important things. That's why the built-in things are there. But that's not important. So let's just define that and make sure that this platform has this ground layer. Okay, you can select it now once you have created it. So once we're done with that, let's just go here and let's serialize a private layer mask called ground layer. So this should allow us to know what is the ground layer. Yes. So what should we do? We need to know whether or not we're on the ground. So for this, we can imagine, like, why do we know in real life that we're on the ground? Yes, I think I heard some questions. Some answers actually. Yes. Why do we know we're on the ground? Any ideas?
Ground's exerting a force on us.
Ground's exerting a force on us, too complicated. Think more cognitive, okay?
Gravity. We're touching
Gravity. You're touching it! Yes, you're just touching it! So you know you're on the ground. Okay, but what is touching it? Okay, your feet is touching it. So if your feet is touching the ground, you know you're on the ground. So let's mimic that in the game. So we're gonna get into child objects. So let's go to here and we're gonna right click, we're gonna create empty. So empty does not have anything, it's just empty. Literally, okay? So if you create empty, you don't see it anywhere. So let's go to here and we're just gonna give this a name called player feet. So this lets us know, like, where's the feet of the player. So we're gonna go over and drag this onto player. So if you drag it right on top of player, you should see that it shows up like this. This means that player feet is now a child object of the player. So essentially what this means is that if player is moving, player feet will move with the player. You probably want that to happen because in real life your feet will not just leave your body. Unless you're amputated, then I'm sorry for your loss. But usually it won't happen. So you want it to follow the player object, which is why we made it a child object, such that it follows whatever the player is doing. But right now, if we go here and we zoom in a bit, if we select player feet and give this the move tool, you can see that it's actually in the middle. We don't want that. Your feet is not in the middle of your body. Or at least not vertically. So let's just move this down a bit. And you should be able to see that the middle is lining up with the bottom of the circle. Is that okay? Does anyone have an issue? Yes. What's the problem? Change. It's here. So you select player feed, you click on this move tool, and whatever that both of these intersect is actually where the object is at. So you just move it down. Oh, right, because it's a sphere, as you roll it, it's going to go to a different position. That is correct. We're gonna see this shortly. So I'm gonna keep this here so that you kind of see like where it is. Right, it is rolling with the ball. So the cheesy way to do this is because this is a sphere. We don't want this to rotate, right? We don't want this to rotate. So as you go to player, in rigid body, there's actually something called constraints, and you just freeze the rotation. So that it never rotates anymore. So as you click on play, now we select player feed, and we go into the game scene. You can see that the sphere is not rotating anymore, so the feed stays in the correct position. Ah, magic. Okay, so let's just recap what we did. We select player, we go to rigid body 2D. There is something called constraints here. That is almost at the bottom of the component. Click on it, it's a drop down, and you click on freeze rotation. And you see a checkbox. You can see it? Yes? Good. Okay, I know this is kind of goofy, but if it works, it works. Okay, programmer rule 101, if it works, it works. Don't question. I feel you need to. But now is not the time. So, with that out of the way, is anyone stuck anywhere? Please raise up your hand. Yes, what's the problem? Okay. Good, okay. I need to rush a bit, so if you can't follow, please watch the recordings for the final 10 minutes because we still have a bit of stuff. So, okay. So we need to be able to know if we are on the ground. And the way we can do that is we know if we are stepping on the ground. But how does our body know where our feet is? Okay, because it's attached to us. But this dumb program doesn't know. So we need to explicitly tell it where our feet is. So let's just do that, and we're just gonna give this a serialized field again. So we're just gonna give this a serialized field, and this is gonna call private transform. So transform is a class in Unity that stores the positional data of any game object in a scene. So we're just gonna do private transform player feet, so that we have a way to know where the player feet is at. Is that good? Good. Okay, so now we actually need to go into how we can check it. So to do that, and we want to keep our code a bit more clean, we're going to do this private void. Actually, it returns a boolean. So we're going to do private bool on ground. So let's just return true for now, so that the code editor doesn't give me all the red lines. So how do we check if it's on ground? Is when we step on it. But there is no such thing as stepping on it in a dumb program like Unity. So another way we can do that is we kind of check if it is close enough to the ground. Does that make sense? If it's close enough to the ground. So the way we can do that is return physics 2D dot overlap circle, and for this hang on, let me check the docs. Yeah, so we need a point. So the point is a position, so is the player feet's position, the position property of the player feet transform. Give it a radius. For now we're just gonna give it something very small, because if it's too big it feels like I'm far away. So we need it close enough. So let's just give it probably 0.04f. And give this the layer mask, which is ground layer. And you'll notice that actually overlap circle returns a collider 2D. But we're returning a boolean value. But that works because in all C-type language, as long as the value is not 0, it's actually true.
Never mind.
Yeah, I mean, it works.
So, because just now I put if direction, right?
Yeah.
And it gave me a compile error.
Yeah, because it's a float. But this is a object reference.
Okay.
So if it's an object reference, it returns something, a boolean returns true. C# is not as dumb as C, but it works that way. So now we know that whether or not we're on ground. So if get key down space and we are grounded, we can jump. So let's see if this works. I'm hoping this works. I don't usually do this. I don't usually make platformers. Oh. Okay, because we haven't assigned this yet. So how can we assign this? We just go to player and see that there's a ground layer. Give this the ground layer. And for player feet, we're just gonna drag and drop this player feet from the hierarchy and put it inside. Okay, are we following? Are we good? Just drag and drop. Yes. Okay, not. Okay, drag and drop. Drag from here to here. Put the player feet inside. Okay, if you can't do that, you can click on this and just select player feet. Okay? Good. Go back to the script. Okay, it's a bit more complicated than you have expected. That's fine. Okay, does this make sense? If it's close enough, we're on ground. Yes. Okay, so it's actually something built into Unity, and essentially is going to give you something, so something closed. For example, it's overlap circle. So it's like we're drawing a circle on your feet with a radius of 0.04 units. So if something is in there and it belongs to the ground layer, it returns true. Okay? Does that make sense? So it's like you're drawing a small circle on your feet. If it's close enough to the ground, it returns true. Okay, intuitively is how it works out. Okay, we don't have to know how what is going on. So let's try again. This time with all the things assigned. As you can see, I'm smashing down, but I'm not jumping any higher. So this means it works. Magic. Okay, so at this point, I'm pretty sure we have ended. Let me see if there's anything else. Okay, no. Okay, good. Okay, hopefully you didn't see that next slide yet. Okay, so at this point, we have ended this week's workshop. Good round of applause. You've made a half completed game. Okay, so let's do a quick recap. Today we learned about the Unity Editor UI and how we could use C# scripts to manipulate player input. So here we specifically use things such as getAxisRaw, such that we can get the directional input of the horizontal axis. We also use getKeyDown so that we know when a key is being pressed. And we also use things to reassign a velocity vector onto a game object. So everything looks good. Okay, we are on our way to making the next Hollow Knight or Celeste. Okay. Yeah, they are both made in Unity actually. So you have a choice, but I'm not gonna get into that. That depends on you in the future. So it's a good start. Okay, we are actually doing something. Oh.
You must exit play mode to save.
Yeah, you must exit play mode to save.
I control S and I already on.
Oh no!
Let me see. I didn't say anything.
You can watch the recording.
It's alright. I took notes. It's fine.
Good. Okay, so before we finish today's session, since you have learned all of this, it's actually possible for you to do more advanced stuff. For example, advanced movement controls such as double jump, wall slide, and wall climb. Specifically, these two you have to wait for next week's level design methods. But you can try to make double jump. So to keep you occupied until next week's tutorial and next week's sessions, maybe you can try to mess around with Unity a bit more and try to implement double jump by the end of the week. And then there will not be prizes if you can do that, but it's good practice. Okay. And let me give you a tip. If it works, it works. Okay, don't question why. As long as there's no bug, it works for the current level. Okay.
What about triple jump?
Triple jump. You can do that as well. It's gonna be the same implementation. And so, just do a quick kind of club rundown. Our sessions are held weekly on Thursdays, the same time as now. And we are going to have game jams, industry talks, and you can create games. Okay, Discord server, Telegram server, Instagram page. Okay, if anyone hasn't joined yet, you can use these links here. And yeah, that's it. Okay, so if you have any questions, you can leave back and you can ask us. You can ask me actually, somebody else. Okay, but if there's no questions, you can leave now. Make sure you save your progress.
I mean, I was sitting right here.